This is the introduction to section 7.4. In this case, part 1. There will only be one part to section 7.4. Our objective here today is we're going to find and use relationships in similar right triangles. Now, we've shown how to find similarities in regular triangles, the 3 ways to prove the triangle's similar. Okay, but now we're going to show how to find similarity in right triangles, which is slightly different. Okay, so it says here the essential understanding: when you draw the altitude to the hypotenuse of a right triangle, you form 3 pairs of similar right triangles. Now, one word in there that we haven't talked about, that's the altitude. Let's take a look at that quickly here. The altitude of a triangle, okay, is the perpendicular segment from the vertex to the line containing the side opposite that vertex. Now, they give you 2 choices. Most of the time, you're going to see this choice here. The altitude is the line from one vertex to the opposite side, essentially from this case, the right angle. Okay. In this case, again, this is the type of problem you're going to see most of the time. This is another case of an altitude, in this case where it's on the outside of the triangle, but it's when you draw a line from the vertex to the opposite side and it forms a perfect 90-degree angle. And what will happen is you're going to notice that we have one triangle here, and the big triangle that are all right triangles. And it happens to be that all of those 3 right triangles are similar. So that's what an altitude is. For future reference in there. Okay, so Theorem 7.3 says the altitude to the hypotenuse of a right triangle divides the triangle into 2 triangles that are similar to the original triangle and to each other. So as you look at this, what they've done here is they've taken the 3 triangles and separated them. You've got triangle ABC, which is the big triangle, and then you got the triangle on the left, the right triangle on the left, and the right triangle on the right. And what they're saying now is if you draw the altitude from the right angle across to the hypotenuse and make sure that that's a right angle, then all 3 of these triangles are similar to each other. ABC to ACD, ABC to CBD, and ACD to CBD. Okay? The big one and the small one, the big one, the medium-sized one, and then the small and the medium-sized one are all similar to each other. So what they're going to ask you to do first here is they're going to ask you to identify with a similarity statement what the 3 triangles are in the diagram that are similar. What similarity statement can you write relating the 3 triangles similar? So what I want you to do here is take a moment and see if you can figure these out before I go through these. Hit pause and then come back to it and see if you get them correct. I want you to write down what are the 3 triangles that are similar from these 2 pictures. Okay, so now that you've hit pause and you've written down your triangles, let's see if they match up with what I have. First of all, we're going to start out with the small triangle on the right. We're going to call that triangle X. We're going to call that triangle XWY. And that's going to be similar to triangle. In this case, let's take the medium-sized one next, and we're going to call that YWZ. You know, you'll notice every time I've done it so far, excuse me, that the right angle has been the middle one, and I've started with the short side, so I went short side to right angle, and that's going to be similar to triangle, in this case, XYZ. Now, again, as you're looking at these 3 things that you're going to have matched up, you're going to have to make sure you have them named properly. To be honest, to me, the easiest way to do this is so that you have the right angle as the middle angle every time. And go short side to right angle. That's kind of the easiest way to sort of remember it. Okay, so let's take a look at this one. What similarity statement can you write relating the 3 triangles in this one? Okay, this is what I came up with here. I go triangle. I went big first, QPR is similar to triangle PSR, which happens to be the triangle on the right, which is similar to triangle QSP, which is the small triangle. So you've got one triangle, you've got 2 right triangles, and then you got the big one, which is 3. Okay. So this is what they're going to ask you to do to start. They're going to ask you to write similarity statements relating the three triangles in the diagram. So you have to just essentially state that the three triangles are congruent. Okay, now you'll notice in your notes that on the next page of your notes, you have corollary to theorem 7.3 and the corollary to theorem 7, corollary 2 to theorem 7.3. Now, I'm going to shortcut those, and we're not going to get into messing around with sides and side lengths and all that stuff. We're simply going to write, I want you to write this down, and we're going to simplify this way easier for yourselves. Okay, so essentially what's going to happen is we're going to just do this with substitution. Now, what the corollary state is that you can make certain sides proportional to others. Now, I've got our figure of three right triangles here. And what I want you to do is be able to write this out on somewhere in your blank spot in your notes and fill this in. This is very important because what I'm going to do is give you the three formulas that are essentially how they get the three formulas to the corollary. Okay, and we're going to shorten this up way easier rather than using side lengths. So I've put in letters here on each side, and you'll notice you've got A here for the big side, B here for the big triangle, and then C. Those are the easy ones. You've got the right triangle here on the right side. You've got F, E, and B, and then the small one, you've got A, F, and D. Okay, so now what it says is that certain sides are proportional. So the things that we're going to write down here, we're going to start with F. The altitude, F, okay, the altitude, which is F, because remember, it goes from the right angle to the opposite side and it forms a 90-degree angle, is going to be equal to the square root of D times E. And you'll notice D times E is the length of the hypotenuse. Okay, and it's really the two shorter sides of the hypotenuse separated together. All right. Now, the next one we're going to look at is letter A. Letter A is the short side of the big triangle, and that's going to be equal to the square root of the whole hypotenuse, big hypotenuse, times the small part of the hypotenuse, D. Okay. And then the third equation that's going to be important is that the third side of the big triangle is going to be equal to, again, the square root of the hypotenuse times the longer side of the hypotenuse. And you'll notice that a couple of things that are kind of easy here for you to notice here. As you look at you solving A and D go together, and B and E go together. Those are the sides that are on those small triangles. And you'll notice in the equations it's the same way. And they use the big hypotenuse. Okay. So now what you're going to do is you're going to use these three formulas to be able to calculate certain sides that may be missing in your similar right triangles. Okay. Okay, so now as you'll notice here, I've went down to the bottom of the page and I've got our examples over here that we just did and our formulas. So now what we need to figure out is we need to move our triangles so that we can figure out what sides are going to match up. Okay, because the triangle is not always going to necessarily be in the same position here. So essentially this is just substitution if you can figure out what the short side is, what the long side is. Now, if you, as you're looking at this, okay, as you're looking at this, A, something else you might want to write down, A is the short side, is the short leg, and B is the long leg of the big triangle. Okay. So as we're looking at your shapes and we're trying to plug in here and we do this, that's how we're going to have to be able to figure that out. So as we look at this first example here, what are the values of X and Y? And we've got, in this case here, you'll notice that we've got an X here, we've got Y. And what we have to do now is we have to figure out what letters and where the numbers are that match up with what we have here in this picture. So I know for sure that y is where f is. So I know in order to figure out y, I have to use this formula. F equals the square root of d times e. And in the problem, you'll notice that d, again, d happens to be here, and e happens to be here. So now I know y goes in for f, the square root of d times e, which is 4 times 12, which simplifies to the square root of 48. And now we have to tie in the fact that we're looking for to simplify the square root. So now what is the largest perfect square that goes into 48? Well, that happens to be 16. So this is the square root of 16 times 3. And then when I simplify that, that's 4, because that comes out, this is the square root of 16 times the square root of 3, which is 4 times the square root of 3. So I know y is 4 times the square root of 3. Okay, now x. X happens to be matched up with letter A. And this would be letter B, and that would be letter F. Okay. So, letter A, as I'm looking at this one here, A is equal to the square root of C times D. Well, remember C is the length of the whole hypotenuse. So A is going to equal the whole hypotenuse here, 4 and 12 is 16, times D, which happens to be 4, which 16 times 4 is the square root of 64, which the square root of 64 is 8. So in this case, x is in the same position as A. X is going to equal 8, and y is going to equal 4 times the square root of 3. Okay, so it's simple substitution as you are looking at these problems here. Okay, figuring out which letters is it that I need. Okay, what I want you to do is I want you to do this second one on your own and have this ready for class tomorrow and see if you can figure that one out. Now, let's take a look down here at the bottom of the page. And let's take a look at problem number 4 first. Okay, problem number 4. Now, again, I'm going to match this up, and I'm going to zoom in on this a little bit here. There we go. So that we can talk about this a little bit better. Now, I'm going to put in the letters in red of our triangle. We know that this is F, and I know that this is A, and A matches up with D. So this, I'm going to erase this A and make this a D, and I know that this is E, and that's C, and this is B. Okay, so I need to figure out what letter D is. I need to know letter D. In this case, as you look at your formulas, which ones have letter D? Well, I've got F equals the square root of D times E, or A equals the square root of C times D. In this case, do I have how much letter F is? No, so I'm not using this one. I know how much A is. A happens to be 6. Square root of C, C is 12. Times D, I don't know how much D is. That's what I need to figure out. So, all I did was substitute those values into that equation. How did I figure out which equation to use? Well, I don't have an F, and I don't know how much E is. So I can't use those two. So now it's 6 equals the square root of 12D. And I have to solve this equation. How do I get rid of a square root? Well, I'm going to square both sides to get rid of a square root. So this is 36 equals 12 times D. Now I divide by 12, and D is equal to 3. Okay. All right, so let's take a look here at. Okay, now this concludes section 7.4 part 1. We'll take a look at these last two at the beginning of class tomorrow, so make sure you complete your WSQ.